Arc fault circuit interrupter, or AFCI, protection is a critical safety feature in modern electrical systems. These devices are designed to detect and interrupt electrical arcs, which are dangerous unintended electrical discharges that can cause fires. The National Electrical Code, or NEC, mandates the use of AFCI protection in specific locations within residential dwellings to enhance fire safety. Specifically, the NEC requires AFCI protection for branch circuits supplying outlets or devices installed in dwelling unit bedrooms. This requirement aims to protect occupants while they are sleeping, as bedrooms are often where people are most vulnerable to the dangers of electrical fires. The NEC defines a dwelling unit as a single unit providing complete and independent living facilities for one or more persons, including permanent provisions for living, sleeping, cooking, and sanitation. This definition typically encompasses houses, apartments, and similar residential living spaces. However, the NEC distinguishes between dwelling units and other types of occupancies, such as hotels, motels, and similar transient lodging facilities. While the NEC mandates AFCI protection in dwelling unit bedrooms, it does not extend this requirement to hotel rooms. This distinction is based on several factors, including the nature of the occupancy, the typical duration of stay, and the potential for supervision and maintenance. Hotel rooms are generally considered transient lodging facilities, where occupants stay for a limited time and do not establish a permanent residence. As such, the electrical systems in hotel rooms are often subject to different requirements and standards than those in dwelling units. The NEC recognizes that hotel rooms are typically subject to more frequent inspection and maintenance than dwelling units. Hotel staff are responsible for monitoring the condition of the rooms and addressing any potential safety hazards, including electrical issues. This ongoing supervision helps to mitigate the risk of electrical fires in hotel rooms. Furthermore, hotel rooms often have different electrical usage patterns than dwelling units. Guests in hotel rooms typically use electrical appliances and devices for shorter periods and may not be as familiar with the electrical system as residents in dwelling units. This difference in usage patterns could affect the potential for electrical hazards and the need for specific safety measures. While the NEC does not require AFCI protection in hotel rooms, it does mandate other safety measures to protect occupants from electrical hazards. These measures include ground fault circuit interrupter, or AFCI, protection in bathrooms and other wet locations, as well as proper grounding and bonding of electrical equipment. Hotels are also required to comply with other applicable codes and standards, such as fire safety regulations and building codes, which may include additional requirements for electrical safety. It is important to note that the absence of a specific AFCI requirement in hotel rooms does not mean that these spaces are inherently unsafe. Hotel operators have a responsibility to maintain their facilities in a safe condition and to address any potential electrical hazards promptly. Regular inspections, maintenance, and staff training are essential to ensure the safety of hotel guests. In addition to the NEC, other organizations and agencies may have recommendations or requirements for electrical safety in hotels. For example, insurance companies may require hotels to implement certain safety measures as a condition of coverage. Hotel operators should consult with qualified electrical professionals and other experts to ensure that their facilities meet all applicable safety standards. In summary, the NEC requires AFCI protection in dwelling unit bedrooms to enhance fire safety. However, this requirement does not extend to hotel rooms, which are considered transient lodging facilities subject to different standards and regulations. While AFCI protection is not mandated in hotel rooms, other safety measures are required to protect occupants from electrical hazard. Hotel operators have a responsibility to maintain their facilities in a safe condition and to comply with all applicable codes and standards. The decision to require AFCI protection in residential bedrooms and not in hotel rooms reflects a balance of factors, including the nature of the occupancy, the duration of stay, the potential for supervision and maintenance, and the specific electrical usage patterns. The NEC is a dynamic document that is updated regularly to reflect advancements in technology and changes in safety standards. As such, The requirements for AFCI protection and other electrical safety measures may evolve over time. Electrical professionals and hotel operators should stay informed about the latest updates to the NEC and other relevant codes and standards to ensure that their facilities meet the highest levels of safety. Furthermore, it is important to consider the potential benefits of voluntary adoption of AFCI protection in hotel rooms. While not required by the NEC, installing AFCI devices in hotel rooms could provide an additional layer of safety and reduce the risk of electrical fires. Hotel operators may choose to implement AFCI protection as part of a comprehensive safety program or as a way to differentiate their properties from competitors. The cost of AFCI devices has decreased over time, making them more accessible and affordable for a wider range of applications. As technology continues to advance, it is possible that AFCI protection will become more prevalent in hotel rooms and other non-residential occupancies. Ultimately, the decision to install AFCI devices in hotel rooms is a matter of balancing the costs and benefits and considering the specific needs and priorities of the hotel operator and its guests. In addition to AFCI protection, ground fault circuit interrupter, or GFCI, protection is another important safety feature in electrical systems. GFCIs are designed to detect ground faults, which occur when electricity flows through an unintended path to ground. Ground faults can be dangerous and can cause electric shock or electrocution. The NEC requires GFCI protection in specific locations where there is a higher risk of ground faults, such as bathrooms, kitchens, and outdoor areas. GFCIs work by monitoring the current flowing in the circuit and comparing it to the current returning. If there is a difference of more than a few milliamperes, the GFCI will trip and interrupt the circuit. This interruption occurs very quickly, typically within milliseconds, which is fast enough to prevent serious injury. GFCIs are relatively inexpensive and easy to install, making them a cost-effective way to improve electrical safety. They are available in various forms, including receptacles, circuit breakers, and portable units. When installing or replacing GFCIs, it is important to follow the manufacturer's instructions and to ensure that the device is properly grounded. Regular testing of GFCIs is also recommended to ensure that they are functioning properly. To test a GFCI, simply press the test button on the device. This should cause the GFCI to trip and interrupt the circuit. To reset the GFCI, press the reset button. If the GFCI does not trip when the test button is pressed, it may be defective and should be replaced. In addition to AFCI and GFCI protection, proper grounding and bonding of electrical equipment are essential for electrical safety. Grounding provides a path for fault current to flow back to the source, allowing the circuit breaker or fuse to trip and interrupt the circuit. Bonding connects all metal parts of the electrical system together, ensuring that they are at the same electrical potential. This reduces the risk of electric shock if someone comes into contact with a metal part that has become energized due to a fault. The NEC specifies detailed requirements for grounding and bonding, including the size and type of grounding conductors and the methods for connecting them to the electrical system. It is important to follow these requirements carefully to ensure that the electrical system is properly grounded and bonded. Regular inspections of the grounding and bonding system are also recommended to identify any potential problems. Another important aspect of electrical safety is proper wiring practices. This includes using the correct size and type of wire for the application, making sure that all connections are tight and secure, and protecting wires from damage. The NEC provides detailed requirements for wiring methods, including the types of wiring allowed in different locations and the methods for installing and supporting the wiring. It is important to follow these requirements carefully to ensure that the wiring is safe and reliable. Overloaded circuits are a common cause of electrical fires. An overloaded circuit occurs when too much current is flowing through the wires, causing them to overheat. This can happen if too many appliances or devices are plugged into the same circuit. To prevent overloaded circuits, it is important to use the correct size circuit breakers or fuses to protect the wiring. Circuit breakers and fuses are designed to trip and interrupt the circuit if the current exceeds the rated value. It is also important to avoid plugging too many appliances or devices into the same circuit. If you are unsure whether a circuit is overloaded, consult with a qualified electrician. Extension cords are a convenient way to provide power to appliances and devices that are located far from outlets. However, extension cords can also be a safety hazard if they are not used properly. It is important to use extension cords that are rated for the application and to avoid overloading them. Never use extension cords as a permanent wiring solution. If you need to provide power to a location on a permanent basis, install an outlet. Damaged or frayed extension cords should be replaced immediately. Never run extension cords under rugs or carpets, as this can cause them to overheat and create a fire hazard. Portable heaters can be a convenient way to provide supplemental heat in a room. However, portable heaters can also be a safety hazard if they are not used properly. It is important to keep portable heaters away from flammable materials such as curtains, furniture, and bedding. Never leave a portable heater unattended while it is in use. Make sure that the portable heater is placed on a stable, level surface. Do not use portable heaters in bathrooms or other wet locations. If you are using a portable heater, make sure that the room is properly ventilated. Carbon monoxide detectors are essential safety devices that can protect you from carbon monoxide poisoning. Carbon monoxide is a colorless, odorless gas that can be produced by burning fuels, such as natural gas, propane, and wood. Carbon monoxide poisoning can cause serious health problems and even death. Carbon monoxide detectors should be installed in every home, especially near sleeping areas. Test the carbon monoxide detector regularly to make sure that it is functioning properly. Replace the batteries in the carbon monoxide detector at least once a year. Smoke detectors are another essential safety device that can protect you from fire. Smoke detectors should be installed in every home, especially near sleeping areas. Test the smoke detector regularly to make sure that it is functioning properly. Replace the batteries in the smoke detector at least once a year. If a fire occurs, evacuate the building immediately. Call the fire department from a safe location. Do not re-enter the building until the fire department has given you permission to do so. Electrical safety is everyone's responsibility. By following these safety tips, you can help to protect yourself and your family from electrical hazards. If you have any questions about electrical safety, consult with a qualified electrician. They can provide you with personalized advice and help you to ensure that your home is electrically safe. Remember to always turn off power at the breaker before working with any electrical wiring. Use proper personal protective equipment, or PPE, such as gloves and eye protection when working with electricity. Never work with electricity while standing in water or on a wet surface. If you are not comfortable working with electricity, hire a qualified electrician. Electrical work can be dangerous, and it is important to take the necessary precautions to protect yourself. Staying informed about electrical safety and following safe practices can help prevent accidents and protect lives.